So I'm going to talk about something else here, but adopting Juha's language, let me say expressions are great. They are of great value because they can be evaluated and they give you values. And that's kind of the core idea of expressions. So in this chapter, we talk about different things with respect to expressions. For example, we talk about expressions in different programming languages because they appear in every language. I mean, there's no language I know of that doesn't have expressions in there. And some programming languages have nothing else. It's just an expression, right? If you go into extreme functional programming, everything is an expression. So they're kind of a great tool in the language. One of the things we focus on in the chapter is how to represent expressions. You could call it, following Juha, a kind of notional machines, maybe to some degree, visual representations. Some of them are actually used in the kind of IDEs you use, like if you play with Scratch or Snap, then the blocks are nested according to the structure of the expression. You plug sub-expressions into those holes in the blocks. If you follow the Bootstrap curriculum, for example, then they draw those circles of evaluations where the parentheses of scheme become circles and are nested accordingly. And then they explain how they get evaluated. Another way to represent an expression is as a tree, computer science upside down tree. And then you can say evaluation actually goes bottom up in that tree. And you can make it explicit. You can explain it to students how those values come out of those expressions. Another part of the chapter is activities. I think there are some fun activities like playing with dice or talking about pool. Also about expressions being used not just to do arithmetic, but you do expressions also for Boolean expressions, like for conditional statements. And speaking about that, that's a little bit of a misconception that expressions would only be for arithmetic. So we talk about a sequence of misconceptions that are specific to expressions. For example, that a single thing like the number 15, that sometimes students think this is not an expression, that's just a number. But even a number is an expression. It's kind of an atomic one. And so we point to a website that has a list of those expressions also with more information. But the chapter lists the key ones about expressions. That's it.